Unfortunately, it looks very much like all of that money that you're saving at the gas pump these days is going to go directly to pay your electric bill starting in January. While not all the rate hike decisions will be final until later this month, enough is known already that you should prepare yourself for these hikes and educate yourself on how to find the best electric supplier.
So, what I want to talk about today is this idea of electric bills. How do we determine how much it's going to cost, and what influences those values? And then what we're going to actually do is be able to figure out how to calculate our own electrical usage, and then from there figure out the cost that goes along with that. So, let me pull up on the screen real quick my iPad. Yay! Look at our little energy mascot, our little electrical mascot here. I want to talk about the idea, first of all, of power of a light bulb. So we talk about this power of a light bulb as being something like, for example, 90 watts. Now we know the wattage determines how bright our light bulb is. So what we're going to look at a little bit more as we go through this is what influences how bright that light bulb is, what factors encourage or influence that idea of power, and what does that power really mean as far as what we see. So, to begin with, let's talk about what the idea of power is in general. We really briefly touched about this idea of power in a circuit as we were looking at our series and parallel circuits. So, let's first of all kind of go through and walk through this piece. So, power. Let's first of all talk about the idea of our current. As our current gets bigger, so in other words, as my flow gets bigger, my power goes up. And we actually see our light bulb getting brighter as the current gets larger. In addition, we also talk about the idea of the battery, a bigger battery or bigger voltage. As the voltage goes up, more push, more flow, it causes my power to go up also. So we've been looking at power so far as just being power equals current times voltage, or our PIV equation. Now, as part of those units, we said that our power units, from what we've been talking about, are watts. So we're going to talk more about what this means in terms of a light bulb in just a moment. We're actually going to look at power from a slightly different perspective. So far we've been looking at this PIV, and we use units of watts, but it actually looks a little different for us now. When we talk about the idea of power, we actually talk about this light bulb in terms of how much energy it uses. So the more power it's utilizing or dissipating, the more power it uses, the more energy it uses per amount of time, per second. So when we actually talk about this idea of power in terms of our purposes now, we talk about this idea of energy per amount of time. Energy per amount of time. So some of my students call this equation our PET equation. P equals E over T. So when we talk about this idea of power, we actually are looking at, and if you kind of look at this equation, we're looking at units of energy, which actually are joules. Those are units for energy, over our units for time, which are seconds. So really that's what we talk about as being a watt. We're going to talk more about this idea of joules as we get into our next couple units. But for our purposes, though, and what we're going to look at today and how we analyze this idea of electricity and usage of various appliances, how much that costs, we're going to look at this idea of the PET equation. Power equals energy over time. So, first of all, when we talk about the electric company, what do we really buy? What are we really buying and from the electrical company? A lot of people say electricity, but that's not quite right. And it's not really electrons that we buy, it's not current. Actually, what we buy is based off, or we can kind of determine it from the name of the company that we buy it from. So in our area, we buy from We Energies. We Energies. And We Energies allows us to buy energy. So the idea is that we purchase our energy from We Energies. We purchase energy. So basically, we buy bundles of energy or certain amounts of energy that they're producing. Now, that brings up the next question is what do we purchase? What kind of units do we use when we purchase this energy? So energy units can come in the form of joules. It can come in the form of a wide variety of other areas, but what we actually buy from We Energies are kilowatt hours. Kilowatt hours. So not kilowatts per hour, but actually kilowatt hours. So we're going to want to look at what is a kilowatt hour. What is a kilowatt hour? How can we calculate that amount? And then go from there. So to begin with for all this piece, let's start to look at this idea of a kilowatt. So typically when we talk about this idea of units, we usually don't use kilowatts. We usually use watts. And when it comes to time, instead of hours, we typically use seconds. So what I want to do is see if we can figure out how many kilowatt hours are in 1 watt second. So in other words, when we talk about this idea of what we buy from the energy company, how does it relate to our standard science units, So let's kind of walk through that. Kilowatt. So if we know we have a kilowatt, think of it like a kilometer or something along those lines, a kilogram. In a kilogram or kilometer or something along those lines, we actually talk about 1,000. So 1,000 watts are in 1 kilowatt. Now, when we talk about 1 hour, we know that we actually are talking about 60 minutes, which is the same thing as 60 minutes and 60 seconds in every minute. So 60 seconds times 60 minutes actually gives me 3,600 seconds in 1 hour. So when we talk about the idea of a kilowatt hour, we actually are talking about 3,600,000 watt seconds. And a watt second is the same thing as a joule. That's what we use, joule. So the idea is that the energy company is basically consolidating down the numbers to make them not quite so big and crazy. So they're a little smaller. So instead of talking about watt seconds, we talk about kilowatt hours. So that brings up the next piece in terms of equation. So what equation do we use when it comes to finding and calculating our energy? So if we look at this idea of a kilowatt, we said that a kilowatt is actually coming from power. So let's use that as a foundation. We were just looking at this idea of our power as being equal to our energy over our time. So if we solve for energy is actually just going to be equal to, as far as the equation wise, power times time. So power, when we talk about the idea of power, we talk about kilowatts. And for time, we talk about hours. So that's what we buy. We buy kilowatt hours by looking at our power rating. So think of it as like a 60-watt light bulb and being used for 2 hours of time. So kilowatt hours. So that's an equation you definitely want to write down. Energy equals power times time. All right. So let's talk about how much a kilowatt hour actually costs. So this is my most recent bill from We Energies. When we look at this idea of what I purchased and what I had to buy for my house, if you look at it, you'll actually see that they have on here our rates. They charge me based on the number of kilowatt hours that I use. So apparently I used 184 kilowatts of energy, and they charge me 0.131110. In other words, they charge me about 13 cents per kilowatt hour. 13 cents per kilowatt hour. So we're going to figure out what that means. So 13 cents per kilowatt hour, we're going to determine what that means and what that's all about. So let's go through an example of how we can do these calculations and what this means. So let's go through looking at a floodlight. So 1,000-watt floodlight is a really, really, really bright floodlight. Usually we talk about like 60, 90-watt light bulbs. So what we want to do is figure out if I keep that wattage, so in other words, my power of my light bulb is 1,000 watts, and I keep it on from dusk till dawn. So I guess just to make it easier, that's considered dusk, 6 p.m., and dawn, 6 a.m. And if I do that, I'm using a time of 12 hours. 12 hours that it's going to be on. And it's asking me how much is it going to cost if I keep that light on for a month. So for 12 hours for a total month. So let's consider this 30 days. 30 days. So how much energy is consumed? So I know I'm keeping it on for 12 hours times 30 days. So my total amount of time that I'm going to be keeping it on, my time is going to be 360 or 360 hours. 360 hours. So if I want to find my energy is equal to my power times my time. Now remember when we talk about the idea of power though, we want power in kilowatts. So let's convert our 1,000 watts into kilowatts. In other words, I'm going to divide it by 1,000. So if I do that, if I divide it by 1,000, I actually get my watts, 1,000 watts, to be converted into 1 kilowatt. So energy-wise, I am going to be using 1 kilowatt for 360 hours. So therefore, the amount of energy that I'm using is actually just 360 kilowatt hours. Kilowatt hours. So I actually already just solved for that. How much in kilowatt hours? 360 kilowatt hours. So then the question is, how much am I going to have to pay to be able to do that? So if I know that I'm using this light for that much energy, and I know in this case they're telling us that our energy cost that they're estimating on here is 12 cents per kilowatt. I can find my cost by looking at how much I am using. So I'm using a certain amount of energy, and they're charging me with a certain rate. A certain rate. So if I go through this piece, I can find my cost then as being 360 kilowatt hours times my 0.12 cents per kilowatt. So let me just plug that into my calculator real quick. So I have 360 times the 0.12, and as a result, I end up getting 43.20 cents actually. So what we're noticing is that the cost of this light bulb, this really bright floodlight for a large number of hours and with a relatively expensive energy cost, is actually pretty costly. $43.20. Now, typically, you won't be using that much energy for one light, but that kind of gives you a perspective of how much energy does cost if you use it and keep lights on for large quantities of time. So what we're going to do now is this. I want you to work on using these ideas to finish up a homework set. This is one of the last homework sets you have for this unit. It is going to be E, and this is actually, I changed the name of this, so let me change your name on here too. This is actually going to be E, energy cost analysis. And you'll be able to get a link to that file either from handouts under Google Drive or on a Blackboard. So E is the file you're going to finish. Submit that using your submission form when you're done. But I have one thing, the last piece of that handout, of that worksheet you're going to be filling in, it asks you to analyze your own device in your home. Now, this is actually my microwave. So if you look at this, if I want to figure out my energy cost for my microwave, I can actually go through and find in my microwave inside the door. This is exactly what I just took a picture of it. And what you actually see is that the energy rated, or the power rating for my actual microwave is 100 or 1,550 watts. So 1.55 kilowatts is my power. So you're going to do something like that too. You're going to go find it, and if you want to look it up online, that's fine too. But find a power rating for some sort of appliance and figure out how much it would cost to keep it on for a certain amount of time. So once again, find your energy in kilowatt hours. So we can kind of outline this. Find your energy in kilowatt hours, and then find your cost. Find your cost from there. All right, hope this helped. Hope you have a good time kind of analyzing this idea of energy, how much energy costs. A great opportunity to really chat with your your parents about maybe how much it costs for your energy bill. I think you can learn some really great things and kind of see a little bit more about even some of the politics that goes along with how these rates are set.